All right, guys. So we are going to go over the answers for 1.4c, more similar triangles practice. So you can see here, it says for number one, the two triangles. Oh, and this is page 71 in your books. Okay. It says here for number one, the two triangles shown are similar. Find the value of a divided by b. Okay. Well, I notice for these two triangles, I don't know A or B. However, because it says that the two triangles shown are similar, and we just learned from the notes section that the ratio of um, the sides being divided by one another will be the same for all of those corresponding sides, I can see here that side A corresponds to this side 2.1. I can see that side B corresponds to this 1.4. So if I set up that ratio for this triangle, or that quotient for this triangle, 2.1 divided by 1.4, and get 1.5 or 1.5, then it's going to be the same for A divided by B. I don't have to know A or B, because remember, this quotient will be the same between any similar shapes. When I'm dividing corresponding those sides by each other, the corresponding sides for the other similar triangles or shapes, that quotient remains the same. Okay? And then we can see the same thing here for number two. It says these two triangles are similar. So again, I know that the quotient when I divide, it doesn't matter which one, we can say that this side divided by this side, that'll give me the same answer as this side divided by this side, okay? But we'll come back to that here in a second. So it says these two triangles are similar. What are A and B? And then there's a little note there, the two figures are not drawn to scale. So in other words, when they say something like this, when they're not drawn to scale, you're not going to be able to just guess it by looking at them. Like you can't hold your pencil up against this side length and say, oh, well, since this is 10 and then this is 2 of my pencil lengths, then that for sure has to be 20, right? That doesn't work because they're not drawn to scale. So we've got to use our mathematical knowledge to figure out what these are. And I'm going to use just what I had said before. Okay, I know I can divide the longer, or actually this would be the medium side. I know I can divide the medium side of this bigger triangle by the short side of this triangle. So 15 divided by 10. And that's going to give me the same quotient as the medium side of this triangle divided by the short side of this triangle. So in other words, that's going to equal A divided by 4. Okay, well I can simplify one side of this, right? I can simplify 15 divided by 10. 15 divided by 10 is just 1.5. And now A is still being divided by 4. I can't simplify that. I don't know what that is. However, now I have this one-step equation. A divided by 4 equals 1.5. And I can just multiply both sides by 4. And that's going to get the A by itself, or get the variable by itself. Well, 4 times 1.5 is 6. I can set up a similar ratio um, to find out what the value of B is going to be. All right, I can see here, I do know two measurements for the smaller triangle. I know I'll do this one in a different color so it's not confusing. I do know the longest side is 9, and I know the short side is 4. So the longest side for the big triangle is B, and the short side is 10. I can figure out what that is by setting up those quotients. Okay, when I do that, 9 divided by 4, I know that has to equal the same quotient as B divided by 10. And then again here, I can solve one side of this equation, or I can simplify one side of this equation. 9 divided by 4 is 2.25. So now instead of 9 divided by 4 equals b divided by 10, I have 2.25 equals b divided by 10. Okay, and then to get the b by itself, all I'm going to do is multiply both sides of the equation by 10, and that isolates the variable. That gets the b by itself, and I see that b equals 22.5. All right, turn to page 72 in your books, and they give us this triangle here, ABC. Now it says it's similar to triangle XYZ, or actually it says it the other way around. Triangle XYZ is similar to ABC with a scale factor of 1/4. Okay, so if I know that triangle XYZ is similar to triangle ABC by a scale factor of 1/4, that's telling me what I need to multiply each one of these sides by to get triangle XYZ. Okay, so if I have triangle X, first thing it says to sketch what it might look like in the space above. Well, if it's 1/4 of what's currently here, right, then let's start with a number that we know, 4. What's 1/4 of 4, right? I can go ahead and say that, well, it's only going to have, well, I might need my marker. It's only going to have a length of 1 for its base there, right? Okay. 1/4 of 5, so 1/4 times 5 is 1.25. So just ever so slightly then, oh, it's not straight up. Whoops. It's just ever so slightly longer than the base. And then I can connect those to finish my triangle, and you can see I have a similar triangle here. Again, we know that this one for sure is 1. 1/4 of 4 is 1. 1/4 of 5 is 1.25, and you might have needed your calculator for that one. And then 1/4 of 7 is actually 1.75. And we might need our calculator for that one as well. Okay. It says draw what triangle XYZ might look like in the space above. We did that, except I forgot to label it, so let's go ahead and label it X. There's Y, and there's Z. I always like to put a little dash through my Z's so you know they're not 2's. Let's answer the next question here. How do the angle measures of triangle XYZ compare to the triangle ABC? Explain how you know. Okay. Well, I just drew it the best that I could. So I can't go based off of my drawings. Okay, I don't have a grid here. I can't say for sure that I actually drew a perfect representation of XYZ. However, remember, when we are dilating a shape, because that's what happened here, right? My scale factor was 1/4, so I multiplied everything by 1/4. So when I'm dilating a shape, that's one of those properties of similarity. The angles don't change. So it says, how do the angle measures of triangle XYZ compared to triangle ABC? They're exactly the same. So they, are exactly the same. And how do I know that? That was one of those properties of transformations that we learned when we were talking about congruence and similarity all the way back in Learning Goal 1.1G. That's what that whole unit, or that's what that whole section was for 1.1, was talking about similarity and congruence. One of the things that does stay the same is the angle measures. What are the side lengths of triangle XYZ? I already have that up there. I already answered that part, right? And then finally it says here, for triangle XYZ, calculate the long side divided by the medium side. So that would be 1.75 divided by 1.25. And then compare that to triangle ABC. So let's write that out first. 1.75 divided by 1.25. And then compare that to triangle ABC. Well, triangle ABC, the long side was 7. the medium side was 5. Okay. Now, if I did my calculations correct, remember these quotients should be the same. Well, when you type it into your calculator, 1.75 divided by 1.25, you actually get 1.4, or 1 4/10. And then when I do that same thing for 7 divided by 5, and I type it in my calculator, 7 divided by 5, I again get 1 4/10. Okay, so how does it compare? It is the same quotient, and it should be, right? Otherwise, we would have done something wrong. All right, last but not least, number 4 here. The diagram shows 2 nested triangles. So one is within the other. That's what that word nested means. That share a vertex. So the vertex that they share, I'm going to zoom in, then I'll zoom back out so we can read the rest of the question. The vertex that they share is right here. That is the, if I were to describe where that vertex is, it's the bottom right vertex for both triangles. Okay, so that's the one that they share. It says find a center and scale factor for a dilation that would move the larger triangle to the smaller triangle. So we're going to dilate about that point. That will be what we dilate from, is right there, because that's where we want the point to stay, because we want to move the larger triangle to the smaller triangle. So let's look at this larger triangle. I'll highlight that one. It is this triangle here. The little guy, I'll shade him in so we can see him a little bit better. But the little guy is all the way in here. Okay. So there's the little triangle, and then I just outlined the big triangle. If I want to go from the larger triangle to the smaller triangle, think about what that means for our scale factor. Our scale factor has to be less than 1. So if our scale factor has to be less than 1, because I'm making the shape smaller, let's see how much less than 1 it's going to be. The way that we're going to look at this is look at each side of both triangles. So I have a vertical side and a horizontal side for both of these. If I count the vertical side for the big triangle, it's 1, 2, 3, 4, 5 high. That's the height of the triangle. For the little triangle, it's just 1. Okay, for the width or the base, it's 1, 2, 3, 4, 5 for the large triangle, and just 1 for the smaller triangle. So I have to go from a 5 to a 1. Well, the scale factor that would take a 5 all the way down to the 1 is to multiply by 1/5. All right. If you have any questions about any of this, make sure you ask your math teacher, and have a great rest of your day. Thanks for watching.